Well, hey, thanks for the good turnout this morning. When I originally looked at my time slot, I was like, oh, wow, that is crappy. Sunday morning at 10 a.m., everybody at DefCon is going to be at church. I'm glad to be pleasantly surprised that you're all here. So with that being said, we're going to be talking to you about some research that has really been percolating for about a year within my mind, and then I introduced Mars to it. I've been doing web application security since around 2004. Worked with every conceivable application security technology from a black box perspective. And the one thing that I have noticed is that unilaterally, the technology has the same problems that Whisker had, or that the most earliest spider technology had, or that the most rudimentary form crawler and fuzzer has. And so there's this common set of underlying weaknesses that have never really been fixed by the development community, by any commercial vendor. And so we've created a methodology and a system for exposing those problems, and it can be used for a variety of ways. And we're going to talk to you about that. The big idea, though, the main overview, is there anybody out here who's ever got a headache from a false positive? You've ran some commercial scanner and you've had so many false positives that reverse benchmarking is to come up with a system that allows us to begin to expose the flaws and the faults in the mechanics of web application scanning technologies without violating the end user licensing agreements. Those little things that you click through have actually caused a significant amount of grief on the part of researchers because you can't just debug the application. It's against the law, of course, to begin opening it up and exposing its object code or looking at how it does its tests. And it's certainly against the law to discuss these publicly. So what's neat about this methodology is that it's totally legal. You simply use the application in the right kind of situation, and those faults will percolate to the top. Now, I would mention just before we get off that we've started a community initiative and a nonprofit, and it's at reversebenchmarking.org. It's also the Orb project, and we're also going to be working with Dennis Cruz and with Site Generator to get our reverse benchmarking methodology built into that. All right, Mars, you want to take it away?
Mars Luck. I've been in security since like 99, I think. I've worked for a lot of places, no place twice. And now the people I work for don't let me actually say I work for them. But continuing on with the rest of our speech, that was the introduction by Tom, and then we're going to talk about just some general concepts in the web application security scanning space, particularly black boxes. We'll talk about the problem of false positives, which most of the people that got up here are probably somewhat familiar with. Then we'll introduce reverse benchmarking and how that's somewhat different from benchmarking or baselining, and then also just go a little more depth into that. We'll talk about 10 of common false positive types, and then further research, and then also talk about some of the statistics that we came up with. Here's an example of an end-user licensing agreement. If you'll notice, it says specifically that you cannot disclose how it works, and that's the part that we think is creating a chilling effect. And the fact that there's actually been very little research in this, and that the idea of reverse benchmarking, while some people have certainly thought of it, no one has actually executed on it. I know OWASP with the site generator idea. Dennis sent out emails, like 2005, starting to scratch on this surface, and it's definitely a problem that's been known since the first of the web application security scanners rolled off the assembly line. I'm going to pass back to Tom for him to talk about his shuriken.
Well, I'm going to skip the shuriken, but I always read this Sun Tzu quote everywhere I go, so I'm just going to read it here. It's the obligatory Kung Fu Sun Tzu quote. And it's whoever is first in the field and awaits the coming of the enemy will be fresh for the fight. And whoever is second in the field will have to hasten to battle. Now, I think when it comes to reverse benchmarking, there's going to be some organizations that are going to be first in the field, and that's really what we want. We really want people to cooperate and to coordinate because we want a community initiative that makes things better. Ultimately, though, there might be some resistance and some vendors and organizations that give us flack or maybe even try and make what we're doing illegal. And in that case, it's great. I'll just take off my pants and call it the Tom Clause. You know, but at the end of the day, we're going to be pushing on because really I'm interested in how we assess and improve the quality of security software overall. We look at things like functionality, the ergonomics, how many clicks through the GUI. These are things that people buy a software product for that does security. Feature sets, it's bling, just do you like the way it looks? But ultimately, at the end of the day as users, we have to deal with accuracy and the rates of false positives, and that's what reverse benchmarking focuses on as a unit of study. So ultimately, there are a few concepts. First off, black box technologies are kinds of scanners that you install from one point. You scan and assess remotely. The idea of black box is analogy. It's sort of just an opaque barrier because you can't see the inner workings of the piece of software. People do this in a way today, and the common technique is a bake-off. Has anybody out there ever had a scanner bake-off, or your company, or you've just ran comparisons? Okay. Well, a bake-off is sort of the opposite of what reverse benchmarking is. A bake-off is a positive type of benchmarking where you're after a comparison of which technology did better or which technology found more and had less noise. Well, reverse benchmarking is a way of making or creating, soliciting false positives and causing massive false positives in any technology where there's a propensity for those things to get out of control. So your goal is not to see who did better, but in a way to see who does the worst. Morris?
All right, here's a little graph that we put together to talk about kind of the criteria that people have used to talk about vulnerabilities. Like in the different type of product lines, vulnerabilities are sometimes understood in different ways. You have the IDS line of thinking, the network security scanner line of thinking, and the web application security line of thinking. But in order to kind of frame this talk and the research, these are just the types of four quadrants that you could possibly have when you're looking for vulnerability. Positive detection would be that you have the scanner finds a real vulnerability that is there. The false positive, which we're focused on, is where the vulnerability is not there, and but the scanner, in fact, finds a vulnerability that isn't there. And so that's the focus. And as things move in the space and web application security scanners become more developed, right, then we can start looking at the higher quality problems, which would be, the face where there is, in fact, a vulnerability, but they don't detect it, right? But that's the mystical part of the industry right now, that we don't know what we're actually missing. But the way our approach is that we'll first be able to look at what false positives are there, and once we can get the false positive rates down in the tools, then we'll be able to move on to the higher quality problems of finding more legitimate vulnerabilities.
Just go back to that chart, to the slide. I just realized, right? I have never seen a tool that gave me a negative detection. I've never seen a tool that says you don't have this. They say I can find it, but they don't say you don't.
No, that's a great point, and it's the massive false sense of security you get from something that isn't digging into your application.
I can find it, but you might have it. That's reach things. The tool actually can say, I analyze the whole shit. Guess what? You can't have the vulnerability.
Yeah. No, absolutely.
It's funny because I never realized that actually there was a gap there. You actually have nobody up there on the top right.
No, that's right. There is nobody. And I mean, we wanted to put it there because it is relevant.
Yeah, absolutely. Questions, those of us in the cheap seats?
Oh, yes. Dennis just mentioned that there weren't any security technologies that would look at the application and tell you this vulnerability is not present. But rather the technologies that exist are all focused on positive types of detection. whereas the technologies that could exist on the false negative and false positive side could even lean toward the certifying of an application, say, against a particular vulnerability type. I have looked at you with the following criteria in detail, and you do not have this vulnerability. That's a much stronger statement than what is currently being made. But ultimately, we want to phase this research into the study of false negatives, but that will be down the line.
Or that would be the ultimate goal of any benchmarking tool, is to do that.
We've spent some time on these slides. I'm not necessarily going to pick up the pace, but I am going to say a little bit less. This is just on positive benchmarking. The idea is typically you figure out what percentage of accuracy did the tools have. Scanner Foodizzle found 8 out of 10 vulnerabilities that we know, therefore its accuracy was 80%. Now that is what people typically do with positive benchmarking, and then they whip out their numbers and decide what to do on the basis of those numbers. The problem is that this methodology as examining or evaluating web application security technologies is limited. There's a lot of factors like this is selection bias. Do you really know what vulnerabilities exist within the sample application you're studying? You might think you do at first, and then until you get the vulnerability data. At this point, it becomes confusing to people, and the process just sort of breaks down. You have to interpret the data. Vendors can tune against a particular application so that you think you've found a particular technology that just does stellar against your set, and then you realize, oh wait, they wrote specific rules for what I was just testing against. Now, this is just a point back that, say, like Site Generator was designed to sort of mitigate the tuning aspect of technologies, and reverse benchmarking is designed just to go underneath that radar, to make something you can't tune against, because we can always create a new fuzz set that triggers your false positives.
The best example there would be like WebGoat.
Yeah, WebGoat, people tuning against it. So, what is reverse benchmarking? It's just designed to kick a scanner's ass, and we're going to trademark that. I think the point, though, is because I work for a technology vendor, I'm not approaching this from my own vendor's standpoint, but that is why I wanted to create a community project, an open project. That way it's out of my hands, because it can't be objective as long as Tom Strassner's doing it. When the community does it, as a community, then it becomes an objective methodology. Now, I'll still participate in this organization as a member of my own company, and that's why we would like other participation, but that's the idea. Yeah, are there any vendors here? Watchfire, Spy Dynamics, Acunetics? Oh, hey, what's up?
Well, it depends on the false positive.
Yeah, absolutely, but that's a good point. And there's also the idea of semantic differences, right? You can pick an obscure corner case that can cause false positives, but how relevant is that to, say, a production environment? It depends on how you're using the methodology, but we need to work out issues like that.
We're definitely focusing on catching the lowest hanging fruit. Right, the stuff that should obviously have been weeded out in some type of QA process. Like in the essence of full disclosure, I used to work as Synzic as well. Overlapped a little bit with Tom, so I know that there's definitely some QA gaps in regard to the industry in general, and that's our focus is catching that low hanging fruit. And so we're not focused on coming up with the obscure corner cases like Tom was talking about, but just doing stuff that is completely wrong.
Okay. So once again, just to make everyone on the same page, what you do when you want to set up a reverse benchmarking environment, whether you're creating itself, and we'll talk a little bit about how you could create one yourself. But ultimately, you have a web application scanning technology, and then you have a reverse benchmarking target or web application with reverse benchmarking capability. There are you might think of as trigger signatures and strings and strange architectures. You can imagine, say, a JavaScript road test that's designed to confuse any type of crawling mechanism and make it believe that there are URIs or URLs that don't exist. You can build within this trigger mechanisms that make it believe vulnerabilities would exist. Ultimately, you scan this application and then just get a report. And if you design the application right, the report can even tell you what types of false positives in a taxonomic sense have been discovered. Now, obviously, that's going to take a lot of research on the part of the community to figure out, well, first, what's a good taxonomy for all of the general and generic, say, false positive types. But ultimately, you're going to enumerate and then categorize the false positives. It will reveal sort of broken or vacuous signatures. If something has a detection signature that's just 200, then it might be triggered by, it's going to be triggered until the year, 2010. So it'll have this false positive for the next 3 years. Well, something like reverse benchmarking can lay that bare really quickly. It'll reveal really semantic flaws in categorization, and it will give you the idea if there are any sort of systemic architectural problems with the technology. When you go through the JavaScript road test type functionality and then into the scanning, you will see where things begin to break down, and you'll see limits in the technology. Marcy, you want to talk about the trends time-wise? We have, we're at 10:16.
Well, I don't really want to belabor this slide. It's just basically the general idea is that applications, web applications, since 99, 2000 have been progressively getting more complex, and the scanners haven't really stayed pace with it. They've taken some definitely increases, but most of the changes in the scanners have been more GUI focused and how fast they can go through their signature base. But changes in the signature base and the technology there is just not really kept up with the GUI development and also the numbers they use to categorize their level.
One of my friends who does manual penetration testing was lamenting to me, and he says, it's getting harder to do my job every year. I'm having to do more work, not less. And it's just because technology is growing faster than the technology we use to, say, perform assessments. And that's one of the reasons why an environmental stressor like reverse benchmarking can help improve technology over the long run, because it's an equal and fair thing that it'll also allow the community to help to understand and educate developers. And that way, one day, when developers are writing new security rules, they'll realize that it's essential to put a no 404 check into a scanner, right? That a 302 redirect should not be considered evidence for a vulnerability. We'll show you some of these false positive types when we get right into them. I'm going to skip ahead a little bit.
Just to give people kind of an idea, like on my day-to-day, it is a lot at doing black box testing of various web apps for large financial, and it's not uncommon to get a 5,000-page report that has a significant number of false positives that have to be manually validated. So, I mean, that takes at least 40 hours of every week just going through that stuff. So that's one of my motivations for doing this is, the self-serving one of, hey, maybe I could work less at some point in the future.
Yeah. So I thought we'd warp ahead and look at the actual types of false positives. And these are real examples of false positives that we're not showing who had it or whose was it. But here's a good example of what we call a partial match problem. Now, as we go forward as a community, we can figure out, say, different terminology or extra false positive types. But I'm calling this a partial match problem because the detection signature was literally a 200, a 200. So anytime a GET request was issued for .pl back, this 200 was matching the date. And of course it will, it's what we mentioned, it will until the year 2010. And so this is something that would have been found in every assessment report ever run by the technology. And the idea there is it's good to know these things because you can weed them out as you're a worker. I mean, if you're using these technologies, it can make your life easier to know what false positive types exist, and you can flag them. Parameter echoing is a big one, and here I've put my very elite PHP script. This, you don't get much more elite than this. You didn't see this at Black Hat. But this something simple like this that's just echoing junk into a text area will really show you a high degree of the semantic level problems with technologies. And let me give you an idea. There is a cross-site scripting vulnerability in this script that's echoing it in the text area, and it's if you break out with a text area tag. However, you will get thousands, or well, so hundreds of different types of cross-site scripting vulnerabilities that are bogus. In other words, semantically, the name of the vulnerability may be a double quote, front tick, backslash, cross-site scripting attack works. Well, that's a vacuous result because everything works. The delimiters are irrelevant. If you encounter a part of the application where the information is being echoed back in a non-executable form, right? And so areas of the application that are just spewing data back can cause false positives because in many cases, one little character that you would need to make it ultimately executable may be missing, or it may be injected into a JavaScript function causing a train wreck, and the data is just not relevant. So parameter echoing, this will give you just one example. If you were creating your little sample application, sticking something like this in there, and then a page behind it with some common strings would give you an example of just how susceptible some of these technologies are. So here's a case of what we call mistaken identity. Now this is a good one because there's so many open source bulletin boards and forums and blogs that everything has become so inbred and cobbled together that you can literally get situations where you'll run a security assessment tool and it will come back and the test will be for search.pl. Okay, I found this Perl script and it tells you, well, this is Alibaba search buffer overflow. But the fact is search.perl matches hundreds of applications out there, so you don't even know what the result is. You'll also find this on if you're scanning, say, bulletin boards and there's cross-site scripting in a Q comment area. Well, until you inspect the application, you don't know if it's real because there have been hundreds of different applications with this same vulnerability, and the name that they're giving you may not even wildly match the technology you're using. So anytime you have issues where just the identity is confused, there's more work for you to do on the back end. And so this is a species of false positive. The other problems that we see are just simple ambiguity, right? The conditions or the string that's used to detect a thing just doesn't go far enough, and that just because they found, say, a SQL error, they're telling you have full-blown SQL injection vulnerabilities. In other cases, there will be some feature of the application that gets picked out, and the vulnerability just resembles nothing like what is looked for. And so these are issues that make reporting confusing and are time-consuming. And so there are areas where studying and categorizing those will be helpful. Mars, you want to?
Go ahead.
Oh, okay. With response timing, this is a really big section because there's a lot of tests for, say, SQL injection that use a wait for delay mechanism. They will just wait for they'll inject a SQL command that will cause the database to count to 100 and then respond back. Well, you can get applications, of course, that are just slow. And so you can see these SQL mechanisms just misfiring like crazy and assigning vulnerabilities to you. So with a reverse benchmarking target, you can just create a portion of the application that is slow and make the timing different or gradable and see how many SQL errors just pop up. This works with blind SQL injection as well.
Or just use portable web app and get that functionality for free.
Yeah. Now with custom 404, this should be ancient. This goes back to the very first scanners of 1998 and 99, written in Perl and put up on root shell. I mean, the problem is if you do not check for a 404 message that's clean, if you are simply keying off of the presence of a 200 OK as a status message, as evidence that the vulnerability exists, then if a web application has set up a custom 404 page where anytime you search for something in the URL, you look for a resource, it's not there, you get redirected to a friendly page that says, hi, file not found, but the underlying status codes are usually a 302 followed by a 200 OK. This causes scanners that don't have this mechanism to go nuts. Now that may seem so old. You're like, no, there's no technology in the world that would still do that today. Well, there is in fact commercial technologies on the market today that perform their file scanning without these mechanisms, and there's a cause of rampant false positives. We're going to look at some real data here shortly. Why don't we segue over into that, Mark, so you can talk about the data segment.
Well, just as an introduction, we called or Tom called the application he originally wrote Back At Ya. Basically, set up that application. It had a number of tests, some of which we've covered. The slide deck will also be up on the reversebenchmarking.org probably later this week after we get back to our respective home bases. We took 4 popular black box web application scanners, ran them against the target with their default policies, and to get these results. I took the results and put them into high-level buckets. Some of the high-level buckets and stuff like that are fairly arbitrary, but we're not specifically saying which scanners did this or did that, and we're not giving out any of that data, so no one should be really concerned. This is just the total false positives for the 4 different scanners as a percentage of a whole. So you can see one of them did really badly. And then the other ones are somewhat similar. So there has been some changes in the community, and some of the products are at a higher state of development, as you can see.
Yeah, just to point that back out, this slide just shows of the total number of false positives we generated, 92% of them were generated by one of the commercial technologies. Now, one of the reasons why this is such a disparate amount was that it did not have a 404 check, so it found 5,000 to 6,000 files that just didn't exist. Just that every backup file in the world and every way you could possibly rename them is in your CGI bin. Now, if you take that data out, they're all sort of doing equally badly, right? And so this isn't meant to say that there are 3 technologies that are stellar and one that's just awful, but really one just had a very, very noisy problem. That
even controlling for that, it would still have had considerably more.
Yeah.
Okay, here's scanner 1's false positives.
Say the percentages.
All right, if you look, the different categories I just put in is path manipulation. It had some type of path traversal or path disclosure types of false positives. There was command injection, Windows, Unix. Probably a lot of people are familiar with that. And then there was all of the scanners had cross-site scripting false positives, which that was just simply putting a script, a JavaScript with cross-site scripting or XSS in just a blank page, and they all triggered on that.
Now, one thing I would add that is interesting, and this shows that there's improvement going on, is that you might think that say cross-site scripting would be the most prevalent vulnerability if you had, say, an echo mechanism like our little elite PHP script. But in fact, in this application, it was only 7%. And the other characteristics, we actually had SQL injection false positives we could generate upwards to, was just 2%. But with command injection and path manipulation, that was combined 72% of the results. And so that shows you areas of security testing where if you were to tighten the testing procedures, implement mechanisms that say, during a crawl, look for the presence of the strings that you are going to use on the basis of detection, and then rule those out as sort of a pre-qualifying run. Well, technology improves. No one's doing that yet. This just shows you how reverse benchmarking could open doors to actually to inspire people to code differently.
With the SQL injection, those are basically strings from SQL servers that just were in text areas in a static HTML page. So that's what generated those. The file disclosure was any type of file, mostly the 404 types of problems Tom was talking about, to where it thought it found a vulnerable file that it didn't. The known vulnerabilities, that categorization was basically any of the semantic types of mistaken identity, where it said, Emily Forums 1.0 had, a vulnerability in PHP blah or whatever. And then misconfigurations were mostly things like to do with the web servers or something like that. With Scanner 2, you can see that the majority of the false positives there with path manipulation And then also, interestingly, the file disclosure as well. So as you can see, there's a dispersion of the problems that are kind of, across the various scanners, that they each have kind of, signatures that can be fooled fairly easy. With very simple problems, low-hanging fruit as we were talking about. Scanner 3, the bulk of them were actually misconfigurations and things that it thought about a web server or a web version or a version of some type of scripting software or something like that that actually wasn't there. And then file disclosure was also a problem with these. Scanner 4 also had the same problem as Scanner 3. These are just trying to give you an idea. The main takeaway here is just that each of them still have, most of these, though some of them, have less functionality and don't necessarily even test for some of these.
What was that, 36? What was that? Was that SQL injection?
Yeah.
Sorry, I'm kind of colorblind.
Yeah. Scanner 4 had a big problem with SQL injection as well. Its SQL injection technology was just pattern matching, and so the fact that these SQL error strings were in the HTML messed with it more than some of the other ones. That's kind of just the. How much time?
Are we going to let them? We can let them download that from the web, right?
Yeah, we're going to put these slides up, and you can draw whatever conclusion you want. This talk is mostly about getting this idea out and trying to get some community support and get people to start submitting false positive scenarios and false positive types to where we can have a bigger set of tests and come up with better road testing applications and kind of we've also talked about having a taxonomy of false positives, because until we truly understand false positives in a more robust scientific sense, I think engineers are going to have a hard time understanding that, and this is going to, or the web application of security space is still going to continue to be more of an art than a science. And so putting some rigor around that is also some of what we're looking to do. For further research, we want to improve the benchmarking target, add more tests, like I said, improve the testing methodology, because right now there's so many different signatures that are kind of thrown out by the application scanners that coming up with the buckets is somewhat arbitrary, and I did that late last night, so it's far from perfect. And then there's also
I would also mention that there's a sort of a dual level here, because dealing with the application spider and what causes the spider to enter erroneous states, get hung in infinite loops, or even find things that don't exist is really key. For instance, if you just take an HTML page that looks exactly like a directory listing, you can find out which of the spiders will begin following the links on that page, thinking that they're entering new directories when they're just following HTML links that just double back onto itself. You can create strange architectures that will expose the faults in spiders. And so when the vulnerability scanning develops sort of a side that is specific to kind of road testing and generating false positives in spiders is good. And Site Generator has aspects of this, because you can dynamically generate pages in JavaScript and Flash. And so I think that there'll be more room for fruitful interaction there. Where were we at? Okay. All right. That's strange. I thought I had 10 more pages to go.
While Tom puts that back up there, just to clarify, the testing target that we used and the testing that we did didn't include any of the type of spider evaluations. So that's one of the other areas to where focus is needed. And like Tom said, Site Generator. So we also just want consumers of these products to be more educated and be able to make decisions based on how accurate and how robust the web application scanner is, as opposed to the marketing GUI.
Mars, tell him I'm going to pull up this sample app, and I'll show him just some.
Okay, he's since we have a few minutes more. going to pull up the sample app and show some of the tests. Okay, and we'll also take questions.
Is it legal to disclose information?
It is not.
Okay, but that was it.
With attribution, I mean, we think it's legal because there's no specific attribution. Dean's Cruise, everybody.
I was just asking, is it legal to actually disclose, on the EULA, right? Is actually to disclose information of what they're not finding. So, because it'd be an interesting loophole, right? Because if the EULA doesn't say you can't disclose what we don't find, or you can't, but they say we can't disclose the results, right? So it's will be covered by there. Although from the OWASP, well, what we will ask actually officially is that we'll ask each of the vendors to actually give us a license. And we were talking about this a couple of days ago, and I think what we'll do is we'll give the vendors one chance to comment on the results, just in case you get something really wrong. So you do the thing, you send the vendor, say, hey, we found this using these are the results we have. Is anything we missed pretty stupidly? And then you run the thing again and you publish the results. And we hope there's no vendor which is stupid enough to actually try to tune their tool to actually match the patterns, because that would be a big problem.
Thanks, Dinas. Anyone else have a question? Or are you ready, Tom?
Yeah, actually, want to just say a few things about kind of the junk that we put into the sample app. First off, just having an area which echoes back, say, things that look like a directory listing, things that look like the output of netstat minus AN. Of course, your default boot INI, where you'll have your obligatory bootloader. Then some dates and directories. Then you have things like Unix or Linux ID command, where it just you on the page following the form, it tells you your UID 0. And so it's things like this that get put into the application that cause trouble for the mechanisms. And it's once we begin to adapt and develop more sophisticated testing procedures, then it's where these methodologies actually improve technology ongoing, right? And so even if disclosure never happens, or even if there isn't a showdown, it's not our goal to make anyone look bad, but it is our goal to expose false positives in a way that help the community understand the problem better, understand a taxonomy of false positive types, help developers when they're writing code go, ooh, I need to avoid these 10 things, and ultimately make the technology better for everyone. Now, with OWASP and Dennis, we may be doing participating in some events and things like this, but the ultimate goal of our methodology is research-oriented and to help an understanding of false positives and to get people from all organizations to contribute so that we can understand the problem better, right? No, and the questions? Yeah. No, it's not available right now. It's a little too ghetto to give out. That's my my attitude of it, but
yeah, we're going to work with Site Generator to come up with some tests, and we've thought of coming up with maybe like a top 10 kind of false positive categories, and then categorize different tests that test for those, which Tom, you want to go back to the the 10 different false positive types that we kind of rushed through?
yeah.
Oh, did you take that slide out?
No. Just so that it's
But anyways, yeah, here, I'll walk out. Okay, not going to work.
the cord has length, but
Most scanners today have configuration options that sometimes help with these things. When you do the evaluation, you try to sort of get to optimum for what a given set of rules and guidelines in the product, get to the optimum of it, or is there really an out-of-the-box?
Yeah, there's definitely the custom 404 error pages that the different vendors have developed, and with custom configuration, when you know your applications, you can certainly weed some of that out. In fairness to all the vendors and to have a baseline we didn't change anything from the vendor's defaults, right? Because if we were whittling around with all the various settings, we could have biased, or at least in the way our thinking was, just use everybody's default policies and default scan against the same target, and that would be the closest to,
Right.
a pure kind of test.
Let me answer in on this too. Also, we weren't trying to do any official benchmark or showdown, and we don't put any stock in our numbers. That's why we didn't tell you who was who. Our goal in getting the results that we did was just to show you that if you take existing technologies and do what we are talking about here to them, you get useful or interesting results. And then those are results that other people can do showdowns or comparisons with. Right.
Actually, that's quite interesting, because you should actually be publishing the two sets of data. You should be publishing the data that says this is our defaults, and then you should publish the data that says this is when you personalization. And actually, the amount of work that you need to go from A to B is also very significant. Because at the end of the day, right? If there's a lot of custom scripting, you probably script the whole thing, right? But you have to write all of that, right, to get those results. And clearly,
that's right. And see, that's where working with you would be a big help, because reversebenchmarking.org doesn't plan to get into the business of comparing or publishing comparisons officially, but we would work with you and OWASP carry that out.
Yeah, ultimately, users tend to, like in the marketing literature, how many clicks to the user can set this off. So I don't think many of those custom, configurations are actually really used by, the vast majority of users of the products. Maybe I'm wrong. Okay, well, there is an alternative opinion.
I usually call them the big button, like the CSSP guys, right? The CSSP guys, you just want to press a button and then grab the 5-page report and go to somebody.
So you're saying the majority of the users of the products are actually very skilled, as opposed to the user base is not very skilled, or?
Two categories, right? And I usually call them one button guys and the consultants, right? One button guys have no fucking clue, right? I call them the CISSPs, right? They always have that, right? Tell you the data they have, right? And they have no clue, right? They just want to press see lots of retro shit. Spam, right? But I think that market is relatively small. I think a lot of the vendors went for that market because it was red, we're just trying to check. But that market has disappeared like a couple of years ago, right? But what happens is then there's clearly a big range of skills from the security consultants.
Thanks,
but
dude.
usually they know what they're doing, right? They usually are technically enough that even if they don't fully understand it, you'll get it. And you might have some elite guys here, but usually who run these tools, and I do a lot of stuff with a code scanning company, usually the guys who know what they're doing. They might not be security experts to the level of they can break anything, but they're usually quite good. Guys are coming in.
Well, that was the easiest way to do the testing, right? Yeah, having some idea of, sorry to cut you off, having some idea of where hours are spent by people and where, how much time is spent and something like that is definitely, I think, useful, and maybe some academic would like to explore that, working with the vendor and having some type of, pool of users, and you can have a control set that were, the clickies and no zero configuration kind of pool, as opposed to, expert power user type of pool, and, do the evaluation across those. But I think that the precondition for that would be some type of reverse benchmarking or benchmarking app, like Site Generator, that can't really be, ahead of time. The scanners can't be configured to, go one for one against its tests. Having some dynamic generation, having both positive benchmarking and the reverse benchmarking types of tests. So, yeah, this talk is just to get kind of the ball rolling and getting people thinking about this kind of stuff, because ultimately, I think there's a lot of time wasted. I know from personal experience, a lot of time going through false positives, even with the various types of tuning, using, multiple different scanners it's still, there's a high rate of false positive. I mean, it depends on a lot of things. There's a lot of different variables that we can't necessarily control for, right now, and might still be very hard to control for in the future, especially with the pace of web application, technology and development. As web services come on, Ajax and stuff like that, just the complexity is going up, and, so.
Also, you had a question in the front?
Well, you're kind of elaborating on that. We have internal users or internal professionals that are scanning that maybe, as you said, somebody from some CISs, that there are also regulatory requirements where you have to have a third party do this for you. And their reports are based on the weight, which is ridiculous. They'll just go through and send you a scan of your network and fix something 300 times and send it to me as a report. And you have to actually go through that crap to what's there. You have to pay them because of the regulatory requirements.
By the way, we're going to be in
What you got to do with somebody else's crap.
We'll be going to the breakout room after this. If you have more questions or you want to sit around and chat, we'll be heading over there after the talk. But yeah, that's a good point.
Yeah, definitely there are, different classes of users, and the audit kind of function or compliance kind of function uses these tools as well.
We actually don't know how much work those guys done. You actually don't know a good example out of the box, right?
Well, it is completely out of the box. The person that delivered it to you, you have never met because you spoke to someone and you had to pay them. Whoever ran it from wherever, you don't know, and they give you 5,000.
Enterprise technologies will also capitulate this cycle. Generally, depending on who did the configuration or how many servers are being scanned, there's generally, not a lot of opportunity to insert yourself into a process and make changes. So it just depends on the functionality that's present, but you can easily find false positives being more of a problem in situations where you either have the technology being configured by a team and then ran over your whole network, where they're not looking at each segment or each specific server, looking over the reports.
So the guys who are running these, they're getting paid by the paperweight, I guess, because they're third-party assessors and you have to have them.
Well, there's certainly, even if there's no motivation and the people have the appropriate skill set, there is still just the fact that this takes a lot of time to do, and if you don't know the application when you hit the ground running and you're scanning something you don't know, you're going to take multiple days just figuring out how the application works. And there's still the case that manual testing, manual pen testing of a web application is more effective than any of the scanners. So no one's published specific real results in that regard I've seen either, but that's kind of one of the big things in the industry that no one really talks about, is that an educated skilled security consultant is still more bang for your buck than people running just commercial tools. But there's the time function of things that you only have 2 weeks to do something or 3 weeks to do something. Like there's costs associated with it. And if we can get the cost of a false positive down, or the number of the false positives down, then people will be able to focus on other types of problems and ultimately be more effective. And the third parties, you can potentially get more effective results from them and more bang for the buck. Because using commercial tools is a necessity, at least in the world I live in. There's no other way to do them. It just doesn't scale doing all manual testing. And using the combination of the two is certainly, the way I approach work is I generally use commercial tools to do a first pass kind of benchmarking, and then I go through the false positives and stuff like that and catch the low-hanging fruit with the commercial scanners, and then come back given time and look for more advanced things with just a proxy and raw tools and stuff like that, because we generally don't ever have time or we given source code, so we do everything black box, and that's certainly more I think it's in some ways more challenging than some of the others, but it doesn't require the level of knowledge that some of the other source code analysis and stuff like that. So in general, kind of the assessment industry is going to have to come up with ways to deal with this, because all the commercial tools, black box, gray box, white box, however you call them, are still not as good as a human, and which is good for us, right? We get paid to do it. but having more effective tools where the humans can spend less time, fighting the tools instead of fighting, vulnerabilities or whatever, is what we're looking for. So thanks, everybody.
Yeah, thanks everyone.